Hello everyone, welcome to another GIS lecture video. And in this lecture video, I want to talk about the components of vector data by tying a lot of the things that we've already kind of talked about together and explaining how vector data at a conceptual level is structured, so how we can bring in the different pieces. So let's go ahead and give ourselves a little bit of room here. Let's talk about the components of vector data. Right. So when it comes to the components of vector data, we've already kind of talked about one of them, but the components are we have some sort of geometry, right? Or put another way, we have coordinates, right? And so this is going to be the points, the lines, or the polygons, right? The things that we think of when we think of vector data. But we also have attributes, right? And we're going to spend a lot of time talking about attributes in the next video when we talk about data types and types of numbers. But really what you can think about with attributes is attributes are the data that is not the geometry, right? So if we think back to our example about collecting information on the fire hydrants, right? You're hired by the county, you go out with your GPS unit, you stand on top of a fire hydrant and you get a point, right? That point coordinate, that's the geometry. But what else might you want to know about a fire hydrant? Well, you might want to know its color, right? If different colors might signify different things. You might want to know what the condition of it is. Does it need to be repaired? Right? You might want to know how far away from the road it is for running hoses and things, right? So there's all these different things that you might want to know about the thing that you're measuring the geometry for. Each one of those pieces of information is called an attribute. And in geometry, right, we typically associate attributes with attribute tables. Right? And so what will happen is, right, just to kind of recap here, right, let's say that we have 3 points, 1, 2, 3, and I'm going to number them. We're at 1, 2, 3, right? On our map or our visualization, right, this is the geometry, right? We're viewing the geometry here. What we have on the back end, right, is we have an attribute table. I'm going to actually give it one more, right? And maybe we have, if these are fire hydrants, right, maybe we have color. Maybe we have quality, right? And so 1 might be red, right? 2 might also be red. Maybe 3 is yellow, right? Maybe 1 is in great shape. 2, right? Maybe 2's been abused. Maybe somebody hit it with their car, right? So it's damaged. Right? And 3 is just okay, right? It's not new, but no one's actively messed with it, so it's just okay. Right? So this idea that we can have information about the feature, right? We store that in a table. It's called the attribute table. And each one of these each one of these columns is an attribute. Right? Each column is an attribute. All right? And each sort of piece here, right, damaged, this is a value. right? So for the second hydrant, right, the quality attribute has a value of damaged. Okay, so let me repeat that. For the second hydrant, right, looking at row 2 here, the quality attribute has a value of damaged. Okay, so that's the second thing. So we can have the geometry, which we've spent a lot of time talking about. We also have attributes, or can have attributes, which is an attribute table where everything is broken up into rows and columns. Think about this similar to an Excel sheet. Now, I've intentionally left this first column empty for a second, and that's because of the third piece, or the third component of vector data. And that is the thing that connects the geometry to the attribute, and that is an ID. Right? Sometimes when we deal with ArcGIS or Esri, you'll see it called OID for object ID, or maybe FID for feature ID. But in reality, all it is it's an ID. And what this is this is a unique identifier that has a one-to-one relationship with, or between, I should say, the attributes and the geometry. What do I mean by this? What do I mean by a unique identifier that has a one-to-one relationship between the attributes and the geometry? Well, I'm being a little bit redundant here in the sense that I say unique identifier and one-to-one. But what I mean is, right, let me use blue here, right? This one right here that I sort of drew here, right? If we add another column into our attribute table called ID, and we go 1, 2, 3, right? This one here corresponds to this one here. And what the ID does is it says, hey, whatever we do to the geometry with an ID of 1, we have to keep track of the fact that it is related to the attributes with an ID of 1, right? It is essentially a key or a connection or a link between the attributes and the geometry, both in terms of keeping track of, if we delete geometry, we need to make sure we delete attributes. If we add attributes, we need to make sure we keep track of which geometry they go for. Or if we move, right, if we move things around. Or in the case of ArcGIS Online, right, you can deal with what are called pop-ups, where you click on a geometry and it'll pop up information. Well, that information is being grabbed from the attribute table directly by saying, okay, what is the ID that they share? 1 and 1. Now, IDs do not have to be sequential numbers, but typically in most applications they end up being sequential numbers, where whatever the first geometry added is a 1 or a 0, and then you add incrementally down the list. But that's all an ID is. An ID is just the number, or I should be more generic, right? The identifier that connects one row in the attribute table to one row in, or one geometry on the map. Now, before we go to the next part, I want to take a second here and I want to actually circle back to that idea of single part versus multi-part. So what would happen in single part, right? This is not an example of either of those really. But if we remember back to single part versus multi-part, what would happen is multiple pieces of geometry would have the same unique ID. That's what it means to be a single part, is that multiple pieces of geometry share a single ID and a single set of attributes. Okay? So these are basically going to be found in more or less every piece of vector data that you're ever going to come across. They're going to have some geometry, they're going to have some attributes in an attribute table, and there's going to be an identifier that connects the attributes to the geometry. There is one final piece that you find in some vector data, and that's going to be topology. And we're going to spend the next whole video talking about topology, but I want to introduce the concept here because it is a thing that is connected to a vector data set. And basically what topology is at the highest level is it is a series of rules and tables that control how different features of the same data set interact with each other. And I'm being slightly simplistic here, but when we talk about examples, you'll see kind of what this means. But the big thing that I want to point out here is that we're dealing with the idea that inside of the vector data, which by default will have at a minimum an ID, a geometry, and an attribute table, we can also enforce rules for how those things play together in terms of in between different features. So hopefully this all makes sense. Again, we're going to talk about topology in the next video. But as always, if you have any questions, please reach out. Thank you.